Okay, key features of functions. They're so cute. Arya Aldebaran. Okay, domain and range. How's domain and range going to help when you're being attacked by a bear? It's not. Okay, anyways, so domain. So there's three things. There's a domain, there's a codomain, and there's a range. And these are special names for what can go into and what can come out of a function. Okay, so what goes into a function is called the domain. Okay, and usually this domain, this is like our x values. Whoa, I don't know how to spell x values. Okay, codomain we'll talk about in a second. The range is what actually comes out. So this is the y values that come out. Okay, the codomain, and we're not going to focus a lot on this, but it is a good word to know. The codomain is the possible values that could come out. So you're only going to get a certain number of y values, but this would be like all real numbers because any number could come out of a function. Okay, so here's a good like picture of this. So say our domain is this, 1, 2, 3, and 4. Well, our codomain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you could keep going with this. It's just all of the possible numbers. But then the range, the numbers that actually come out are 3, 5, 7, and 10, and it's from this function right here. Because you plug in 1, 2 times 1 is 2, plus 1 is 3. And then 2 times 2 is 4, plus 1 is 5. Which, as we can kind of see, you're only going to get odd numbers out of this. You won't get any even numbers. Okay, so that's what domain and range are, and codomain. Okay, so what comes out is the range. What we put in is the domain. And this is just another visual of that same exact thing we're just talking about. And again, just more. So the codomain and range are both on the output side, but they're subtly different. The codomain is the set of possibilities that could come out, and the range is what actually comes out. Okay, so let's do some examples of this. So if we're given this right here, we need to find the domain and we need to find the range. I'm never going to ask you to find the codomain. So the domain here is our x values. So this x value, it looks like the furthest left it goes is 1, 2, 3, 4, 5, so negative 5. And the furthest right it goes are negative 4. 1, 2, 3, 4. Yeah, so x is greater than negative 4, right? And we're going to put a parenthesis there because there's an open circle there, which means that it does not equal negative 4. But then the furthest right it goes is 1, and there is a closed circle there. So that means the domain is going to be from negative 4 to 1, and it's a bracket on 1. And I wrote this part out right here for a reason. So this is called interval notation. And if we need to do it in set builder notation, I think that's what it's called. So for set builder notation, it always starts with a bracket here, and then it's going to be x such that. So this line is saying such that. And then we need to put this down into here. But I only want one x in there. So if I just write this from least to greatest, so I know it's negative 4, and that is less than x, but it's also x is less than or equal to 1. So I just combined this. I put the x in the middle and flip-flopped it. Okay, this is set builder notation. You do need to know both of these. Okay. And there is that set builder notation. Okay, the set of all x such that x is greater than negative 4 and less than or equal to 1. Cool? Yep. Okay, now let's do our range. So range is our y values, and you go bottom to top. You can always think of that stupid Drake song, like started from the bottom, now we here. I hated that song. I've always hated that song. I don't hate Drake, but like, I don't know. Anyways, but range, so the furthest down this goes is -7. And it's equal at -7 because even though it's not like a distinct closed point, you could tell there's a point there. So that's going to be -7, and y is greater than or equal to -7. And it goes up to, what is that, 1, 2? Up to 2. So our range is inclusive for both of these, -7 to 2. And then we want to rewrite that. So -7 is less than or equal to y is less than or equal to 2. Then that's going to be the squiggle y such that y is greater than or equal to -7, less than or equal to 2, and squiggle. Cool? Okay, let's do this one. So domain here is -infinity to infinity, which you can also write that as x exists in the real numbers. So this e right here, like that, this means exists in. It might just means exist, but we can say in. And then this right here is an r, and this means all real numbers. Okay, so that means that x exists in the real numbers. So that means our domain is all real numbers. Okay, and then our range here, .n means natural numbers, z means integers, r means all real numbers. Our range here is -5 to 5, inclusive for both of them. And then we know y is greater than or equal to -5 and less than or equal to 5. So we could write that as -5 is less than or equal to y is less than or equal to 5. So that's going to be y such that y is greater than or equal to -5 and less than or equal to 5. Okay, this one right here, so it looks like we have a break in there right there. That's called an asymptote. So that asymptote, we cannot pass the asymptote. There's no values where that's going to cross. This is just going to go up against here forever. And it's also going to go down forever. So then here, our domain is -infinity to 3. And then u, this means like a union. Always put the u there. And then from 3 to infinity. And we can write that as x such that x does not equal 3. So that's telling us it equals every other number except for 3. Our range here is -infinity to 0, and then 0 to infinity, and y such that y cannot equal 0. Cool? Yeah, I got it. Okay, intercepts. So intercepts are where it's crossing either the y-axis or the x-axis. X-intercepts are where it crosses the x-axis. Y-intercepts where it's crossing the y-axis. So the x-intercept is where y equals 0. And the y-intercept is where x equals 0. And think about that. So x equals 0, that's this right here, right? So x could equal anything, because like this would be 1, 2, 3, 4. This looks like it's like -3 maybe. But the y value here for all of these is going to be 0, right? And we could say the same for this way. So like this would be -1, -2. This looks like it's about, I don't know, 2. But all of the x values here are 0. Okay, so that's why this is true. And we're going to use that to find these algebraically. So here, a function can have 0 or more x-intercepts, but only one y-intercept. So you can have as many x-intercepts as you want, but you can only have one y-intercept. So if we look at these functions right here, we need to find the x and the y-intercept. So this one, the x-intercept, so where it crosses the x-axis, is at 4, 0, and the y-intercept is at 0, 2. These are pretty easy. We're just looking at the graph, right? This one, we have 4 x-intercepts. We have one at -1, 0, 1, 0, 2, 0, and 3, 0. And the y-intercept is at 0, 6. Always write them as points. This one, there is no x-intercept, but the y-intercept is at 0, 5. Cool? So finding them algebraically. So this is where we're going to use like the x-intercepts y equals 0 and y-intercepts x equals 0. So to find the x-intercepts, these are also called zeros or roots. We're going to set y equal to 0 and we're going to solve it for x. To find the y-intercepts, we're going to set x equal to 0 and solve it for y. Or you're going to find f of 0. Okay. So if we're given this function right here, f of x equals negative x minus 5 plus 3, absolute value of x minus 5. Let's find the x-intercept first, so that's where we set y equal to 0, which really y is the same as like f of x in this case. And then we're just solving this, so I'm going to subtract that 3 over, divide by negative 1, so I have 3 equals the absolute value of x minus 5. That's where we get the two cases. So that first one we're going to get x equals 8, and this one we'll get x equals 2. So we have x-intercepts at 8, 0 and at 2, 0. And then our y-intercept is where we're going to do f of 0. So we're just going to plug zeros in for wherever the x's are. So that's going to be negative, absolute value of negative 5 plus 3, which is negative, the absolute value of negative 5 is 5 plus 3. Negative 5 plus 3 is negative 2. So that means our y value, or our y-intercept is 0, negative 2. Cool. This one, so x-intercepts, set it equal to 0 and solve. So I'm going to factor out an x, and then I'm going to factor that, and that factors to 3x minus 2 and x plus 5. And then we're going to set all those factors equal to 0, and you end up getting x equals 0, x equals 2/3, and x equals 5. That should have been a negative 5. That's my bad. This should be a negative 5, because we subtract 5 right there, right? So then our x-intercepts are at 0, 0, 2/3, 0. See, look, I fixed it up there. Like, why do I do stuff like that? And negative 5, 0. Okay. Y-intercept, we're just going to plug in 0 for the x's, which it looks like they all cancel, so that just equals 0. So we have a y-intercept at 0, 0. And we could have noticed that when we found our x-intercept, since we have this one right here. If you ever have an x-intercept at 0, 0, your y-intercept is the same thing. Okay, this one, so 0, we're going to add that 2 over, so 2 equals the square root of x plus 2. Get rid of the square root, we're just going to square both sides. So that's 4 equals x plus 1. Subtract that 1, you get x equals 3, so our x-intercept is at 3, 0. Y-intercept, we're going to plug in 0, so you get the square root of 1 minus 2, which is 1 minus 2, which is negative 1. So that's 0, negative 1. Not bad at all. Cool. Okay, so let's talk about critical points real quick. So critical points are points where the graph changes its direction or shape. So if we're looking at this graph here, we're like going up. You always read it left to right. This point right here, we hit that point and then we start going down. So that means it's a maximum. This point, we hit it and we kind of pause for a sec, but then we just keep going down. If that happens, it's a point of inflection. And it could happen going up also, like you could stop like this and then go up. This would still be a point of inflection. Okay. And then we go down and we start going up again. Well, that's called a minimum there. Okay. So extrema are points on the graph where it changes direction. So this is like our max and our mins. And they can be relative or absolute. And then a point of inflection. Anyways, we just talked about all that. So relative means that it's not the highest or the lowest, but it's just somewhere in the middle, but it's a maximum or a minimum to the points around it. So like these ones, this is obviously not the highest point on the graph, but it's the highest to the points around it. Same thing here. It's not the high or lowest on the graph, but it's lowest compared to the ones around it. This one is the highest, and this one is the lowest. So those are called absolute, where the other ones are called relative. Okay, so I'll probably ask you some questions about finding those. For this one, so increasing and decreasing, you always think about it as you're moving left to right. We read books left to right. We do a lot of things left to right. So that's the same way that we're going to read graphs. And then you can think about it as like you walking along the graph or a turtle walking along the graph. If this turtle was walking right now, the turtle would be walking uphill, right? So that part of it would be increasing. So he would be increasing his slope from negative infinity to 1. It's kind of like climbing a mountain. So as you're like climbing up the mountain, you're increasing in your altitude, right? But then you get to the summit and it might be flat, or if you get up to like a saddle, you might get flat up there. And so that means it's constant during that duration of it. So -1 to 4, he's constant up there. That turtle's just kind of walking. But then once he goes past there, he's going to start going downhill again. So that's where he's decreasing. So he'll be decreasing from 4 to infinity. And you always write increasing and decreasing as x values. So let's write that down. Always write increasing and decreasing, increasing, decreasing, and constant intervals with x values. Okay, that's very important. That's one thing that we tend to mix up on here. So always write it down with your x values. Okay? And I think, oh look, I even wrote it there. That's it. All right, adios, folks. Goodbye.